Connecting. Warning on Twitch. Twitch is live. Okay, am I getting audio? Hello? Looks like we're live on YouTube. I know my keyboard's really loud. Okay. Comments are working. Online. Okay, looks like we have one viewer on Twitch. Feel free to comment. I'll respond as I see them. Oh, that's fun. We're not gonna talk about that. Okay. So we left off last time and we had a game where we can move our player. We had an enemy that falls from the top of the screen and respawns once it gets to the bottom. And then, well, okay. So now we're gonna have to be able to have multiple enemies, and we're also going to have to be able to attack the enemies. So also the enemies have to kill us. So let's first go to do multiple enemies. So I just cleaned up the code a little bit since last time. Cleaned up our enemy class, and that's pretty much it. We can hide this. So I'm going to first change this to be an enemies array. So we're going to have multiple enemies. Then we're also going to define a global enemy count. So we're going to have an enemy count, and we're going to set it to, let's say, just 10 enemies for now. And so we are going to have to make sure we're still streaming here. So we're going to have to so we should probably display the enemies in a grid format and just fill up the screen with the grid format. Alright, first of all, our enemy is moving really fast, so let's slow him down. Probably even slower than that would work. So we could actually, what we could do is, so if we have like let's say our enemies have a max speed of 10, which is their bodies per movement. what we can do is make it so that their enemy color is actually proportional to their speed. So let's look up real fast P5JS HSL. So this is hue, saturation, and lightness. Okay. Got RGB color, transparency, color mode. Okay, HSB is fine. So what this does is I define a hue, which is 0 to 360, or I guess in this case they define 0 to 100. And then you have saturation, so on a scale of like gray to full color, how saturated is it? And then you got brightness, which is how bright the color is. So what we can do is set our color mode. So I'm going to fix this. So color mode. RGB. Set this to 255. Okay, and then we're going to have to set this to color mode HSB. We're going to set it to 100. So this way, what we can do, actually, let's just set it to 1. So here, we're going to leave our saturation and brightness at 1. We're going to take our hue, so we're going to take the speed and divide it by our max speed of 10. Let's just define this. This dot max speed equals 10, and it looks like mistyped there. We're going to have to move this to afterwards. This dot max speed and saturation of 1, brightness of 1. Okay. So now his color should be proportional or not to his speed. Okay, color mode set to fill, define 0 and 255. HSB, let's use HSB system instead. This is color mode. You can also use HSL. You can set the mode and the max for all of them. So I can let defaults. Oh, so I have to define it. Well, here and here, because it doesn't understand. And then when I do it here, I'm going to have to set. Why don't we just move everything to HSB? Oh, caps lock is on. Random HSB color. Can I just, thank you. Okay. Cool. We're going to have this guy. So 39, 74, 100. So you can see here actually a visual representation of what happens. So brightness brings it from black to here, saturation brings it from white to the color, and hue is just all the colors, the rainbow. So we can just put this out here. We'll set the color mode to HSB, and that's it. We'll just leave them as defaults. So now, well, can I leave them as defaults? Does not look like it. So let's just set the max to 1. So now when I set color, I'm going to do 39, and the max there is 360. So 39 divided by 360 to give us a value between 0 and 1. Then here, it's 0 and 100, 74, 100, and here, or actually here, since it's divided by 100, we can just move the decimal place over to, and here, it will be 1. Okay, so that should be our player color done. We can leave that the way it is, and here, we already have the color mode set, so that should be all okay. See if it works. There we go. So let's pick up his speed. So if we change his speed to 5, his color should change. There we go. He's going a little bit faster. So let's actually, yeah, let's just leave it at like 0.5. He goes quite slow then. Yeah, 0.5. Yeah, so he's red, and he'll go through this entire thing. He'll start at red, and he'll speed up. As he speeds up, there he goes. So let's see. There's one. We could say red, orange, yellow, green, blue. Well, okay, we got like green, blue, dark blue, purple, pink. Well, we got like pink and red again. So we got what, 8 colors? Yeah, we'll leave it there. We'll worry about that later. So the different colors correspond with the different speeds. Oh, hey Preet. Sorry, I didn't notice your comment. So different colors are going to correspond with the different speeds. So now we need to make a bunch of different enemies. So we got our enemy count, we got an array. So we're going to use a for loop. We're going to let I equals 0. I'm going to say I has to be less than 10. And then we're going to increment I by 1. So then we're going to do, so we're going to set our enemies at our index to be a new enemy. And we're going to take that index. So this is our, if we look here, this is our size. Currently our x will give a random initial x, but what we want to do is we're going to add back in x because we're going to set these up in a grid format. So what we need to do is take the width. So we need to get, so if we're going to divide up the canvas, right, into equal segments, we need to say, so the size. So we're going to make let enemy size equal, and we're going to, let's up it to 15. So if we want to divide this, so if we want to have enemies and as many enemies as we can fit, let's say there's going to be, I don't know, 5 pixels between every one. So we're going to have to, so each enemy is going to take up 20 pixels of space. It's going to be, and then an extra space on the right. So it's going to be a 5 pixel space on the left. Well, for you guys, it's 5 pixel space on the left. And then it's going to be the 15 pixels of the enemy. So that's going to make up 20 total pixels. So we're going to take our enemy size. We're going to set our margin size of 5. So that's the space in between enemies. So we're going to need to calculate the total amount of enemies we can fit. So we'll calculate it in here because we need access to width. So total enemy size is going to equal, so we're going to take our width, and we're actually going to put that in parentheses. We're going to take our width, we're going to subtract that margin size, just so we have an extra gutter on the right side. Then we're going to take that, and we're going to divide it by our enemy size plus our margin size. And this will give us our total enemy size. Our total enemy space. So when we do our initial x, we're going to take that total enemy space, we're going to multiply it by the I value, so at 0, it'll be placed at 0 plus that little margin. And then, oh, I need to add in that margin, so margin size plus total enemy space times that, and then we should be good to go. We're creating them. So now that we have all our enemies created, we can't just call enemy.draw and enemy.update. So I'm actually going to move the update, all this update stuff, into a function. A function called update sprites. So a sprite is just like a little character that displays on the screen. So in here, I'm going to use a for in loop, so enemy, and well, actually a for of loop. So we're going to take every enemy of the enemies array, and then for each of them, we're going to say for that enemy, update. Okay, so we can just call update sprites. Okay, and then we're going to do the same thing for draw. Draw sprites, player.draw. Okay, then we're going to change this to draw. Okay, boom. So now if I refresh, look at that. Not sure why it's, oh, it's because there are only 10. We need to fix this. So if you look here, it wants the size, and we're putting it as 10 when it's calculating for 15. So we need enemy size in here. Now if I refresh, All right, we're gonna do this differently because that doesn't seem to work quite well. So we're going to take and multiply this, and that should work for the amount of enemies we have. Oh, whoops. This should work, the enemies we have, except for that's on the screen. There we go. Now there's a margin there. So this should work for the amount of enemies we have, but the problem comes when you increase this to 15. Maybe like 25. Let's just call it. Oh, this needs to be enemy count because before we were doing tens, and no matter what I changed this to, it would stay. So now 15 should work. So you see 15, it reaches the edge of the screen. So we don't want that. So we need to figure out the maximum amount of enemies we can fit in here. You can barely hear me. You could turn up your volume, but does that work better? I turned up my microphone a little bit. I can turn it up a little more if you'd like. Is that okay? We can go all the way up. That's as much as I got. All right. Also, the comments should be popping up. There we go. The comments are popping up. So, in order to figure out how many enemies we can fit on the screen, we need to calculate the margin plus the enemy size for each of them, and then we need to divide the total width by that, and then floor the value. So, total enemies in width. It's gonna change. This is total enemies across, we're calling it. So what did I say? We need to floor the value, so we need the lowest integer. So then we're going to need to take the margin size plus the enemy size. Okay, so now we have the space plus the enemy. And then we're going to need to divide that by the total width, but we're going to need to subtract the margin size first, just so that we have an extra buffer here. So now let's actually console log that. So when we refresh the page, it should pop up here. 0. Getting messages. Commander root. He's now following. Shout out Commander Root. Yeah, I don't know much about this Twitch stuff, but I know you can follow people. And I know how to get this video out to you guys, so obviously it seems to be working pretty well. Let me know if you're watching on YouTube as well. Not sure. See, one person's watching on YouTube. Okay, so get back to it. We need to figure out why this is outputting 0. So first, we're going to remove this floor, see if that's the issue. And we're going to see the true output of this division. Okay, so we're getting a really small number here. So first of all, so this is what we would call a logical error. Everything compiles, like everything runs. There's no fatal errors, but it's not giving us the output we expect. So this is what we call a logic error, logical or logic error. So we're gonna output these two things. Refresh that page. Okay, so 20. Oh, okay, yep, that makes sense. So we're dividing 20 by 295, when in fact, we want these swapped. You guys probably already caught that, but that's okay. All right, so here we go. We're getting 14.75, so we can fit 14 and a third of a player on here. So we're actually going to change this to ideal margin size. So this is what we really want, but you know, depending on just how it works out. We're going to have to adjust. So now we know we can fit 14 enemies across. So we are going to then figure out our true margin size. So we're going to take the width and we're going to subtract our enemy size. Oh, also we need to floor this value because we want 14. Because we can't fit, we can't take 3/4 of a player or a sprite. Well, we can, but we don't want that. So we need to take our enemy size, multiply it by our total enemies across. Okay. So now we have all of our enemies' width, and then we're finding the leftover space in between. And then, so if you think about it, we have one margin, then a player. So we have one margin for every player, plus one extra on the side. So we're going to need to take and divide that total space by this plus 1. That's not a 1. And we're just going to put that in parentheses so that it's ideal. So then when we're creating our enemies, okay, then we're going to take our and use our true margin size. And we also have to figure out, then we have to say if, okay, we're going to have to say okay, so we're going to have to say if the I is greater than the total enemies across. So if we're at 15 and we need to hop onto the next line, then let me think. So if we're going to take our total, we're going to take our total enemies across. So if it's greater than, it needs to know to go to the next line and then subtract. Okay. So we can actually do this, without an if statement. So we are going to have to figure out which row it's on. So let row. So we're going to employ something called modulus. So we're going to take our I, and we're going to do modulus 14. So when we divide, oh wait, but that'll return, okay, we're going to say row equals 0. Here we go. We're going to take the I and divide it by 14, by our total enemies across. So what this will do is, if this is less than 14, it'll always output row 0. So row 0 is the first row. So if it's greater than 14, it's always going to output 1 until it gets to 28, and then it'll start outputting 2. So now we can keep track of the row we're in. So we're going to need to excuse me. So we're going to need to account for our row. So what this is going to do is actually, so we're going to take our true margin size. We're going to say so we're going to have a row offset actually. So 0. So it's going to be our row. Okay, so let's say 2 times our enemy size plus our true margin size. So it's going to take the square of us and it's going to shift us back by this much. So we're going to create a row offset. Okay, and so we're going to take our y and we're going to, so it's going to be 0 minus our row offset. Okay, so that definitely didn't work. Sorry if you can hear people talking in the background. So why is that not working? So let's do something that's kind of dumb. Actually, no. Before we blow up our console, let's back down this count to just 5. So we're gonna console log all our x values. So what is happening here? Okay, so our true margin size. First of all, I think they're all on row 1, so we don't have to worry about that. So if you guys see a mistake, let me know. Let me think about this for a second. First of all, let's output our true margin size. Actually, total enemies across money sign. Enemies across. Okay, we're going to copy this. True margin size. True margin size. Who is ship of 12? If you have computations based upon 300 by 300, the width and the height make them variables, so you can change the width and the height without changing every function in the call. Yeah, well, so actually, what happens is in P5.js, when you call create canvas and you give it 300 and 300, it will define for you these variables width and height. So if you look above in my program, I don't define width and height ever. They're just predefined. It's just an easy way to access our width and our height. Okay, so here's our issue. True margin size is being set to 286. That's what it looked like because our first x was at 286. So there's something wrong with our computation here. So, oh, okay, let's not. So we need to relook at this here. All right, let me give myself some space here just so we can focus in. So we need to figure out, so the total width of all of our enemies, so if we were to take 14 enemies across, we would multiply that by 15 to get the total width of our enemies. So if we just had them stacked next to each other, that would be this. So we're getting all the white space. Okay, let's console log some stuff so we can look at some running variables. So we need to figure out what's the width of our total white space. And of course it's going to auto format. So width minus enemy size times, so enemy size times, okay, we know our width is 300. So 210 is our total enemy size, which is 15 times 14, 210. We subtract 300 minus 210 gives us 90. So that is correct. So the error comes in when dividing 90 by 15, which doesn't quite make sense. Oops. So this is interesting. So if I were just to take 90 and divide it by 15, what should we get? 6 is what we should get. But we're not getting, we're getting 286. Okay. Oh! So if we were looking at PEMDAS, you heard of PEMDAS, okay? It's parentheses, exponents, multiplication, division, addition, subtraction. So we have subtraction here, but we have division here. So it's taking all this and dividing it out, and then subtracting it from the total width. And we don't want that. So we want all of this to happen. So if we had parentheses here, boom, there we go. Now we have perfect margins. We can get rid of that. We can get rid of that. So if I were to up my enemy count back to 15, we need to see if the rows will work. And they do not. So it ends up reaching exactly 300. So there's one that's right on the edge here, but too far to the right. So let's get rid of this randomization here. So that they always hop back to the top. So if you saw that last one, it did hop on top. So it looks like the row offset is working, but it's not coming all the way back to the beginning. So it's our X values that are messed up. Oh, okay. So what we need to do is we need to take this entire X value. So actually, let's just take this entire thing, replace it with X. Okay, and then take the Y offset. Make that a variable. Just make these a little easier to understand. Okay, just group things by parentheses, always, even if you don't have to. Oh, good luck finishing your device driver. Thanks for the advice. I usually do group by parentheses, even though I don't have to, just because it's a little easier to look at and understand. So we need to take this entire X value, and then we need to subtract. So our row number times our width. Okay. And there we go, kind of. Our width plus true margin, minus true margin size. There we go. Now we got our grid format going. So I should be able to up this to 30. Let's cross our fingers. Ready? Oh boy. There they go. So our grid is working. We can still move our player around. That never broke. Okay, so now we can handle a ton of enemies. So what if we wanted some to be moving really fast? Or, so what if we wanted it, so once they reach the bottom, okay, so they end up getting faster. Well, we'll add in these little features last time, because, or add at the end. We're just going to try and finish out our basic game here. So we need to be able to shoot. So we're going to need a list of bullets. And for each of those bullets, we're going to need a class. So Let's add a new file. We'll call it bullet.js. Okay, we need to add it to, we need to add it to our index HTML file here. Okay, so here we're going to define a bullet class. We give it a constructor. So we need to define an X and a Y. Okay, and that should be it, because we're going to have the same speed for all of our bullets. So we set this dot x to x, this dot y to y. Okay, so when we draw this bullet, we're going to make a rectangle. We're actually going to set the rect mode to center. So what this will do is, I can actually pull it up for you. The rect mode, what this does is defines how you create a rectangle. So when I say center, this x and y becomes the center, this becomes the width and the height. So now I can draw a rectangle centered around this dot x, this dot y, and we're going to give it, it's going to be a square. We're going to set our fill. What's a random color? Whoops. This is a good one. 6396. Divided by 360. 0.03.96. I forgot there in between 0 and 1. Okay. Oh well, we haven't done anything with it. So we also need an update. So this dot y is going to be minus equals, because remember y plus is going down. So we're going to set it to be to 2 pixels. No, we're going to do 5. These bullets are going to move fast. And then we're going to say if, so let's see, can we destroy self.js? So can I self-destruct an object? Right, so we can't. So we need to handle this in a separate place. So what we can do is, okay, yeah, we're gonna leave it like that. So actually what we're gonna do is we're gonna keep this list of bullets inside our player, since our player is gonna be the one creating them. So this dot bullets equals a blank array. Okay, so we're gonna do create bullet. Well, we're just gonna call it shoot. So this dot bullets dot push. So this adds to the end of the array. We're gonna add a new bullet, and we're gonna provide it this dot x, and then the y we want to shoot from the center of our player. So this dot y plus this dot size divided by 2. So we're going to create a new bullet. Okay, and then when we have we're going to have to say update bullets, this dot bullets dot dot, we can say dot map. So this lets us do actually we're going to keep it a little bit basic. So we're going to do a for of bullet of this dot bullets. We're going to say bullet dot update. Okay, so we're going to copy this, and then in draw, after our player, we're going to draw all of our bullets. Okay, remember, still move our player. So, sketch. Okay, so you don't want to be able to press and hold the you don't want to be able to press and hold and just infinitely spawn bullets. So we're going to do going to go here. We're going to look at key pressed. So this is a function and that's called when the key is pressed. And so we're going to look at our key code. Our key code is there spacebar, space, delete, enter, return, alt, up arrow, option, JS. Keycode.info. I showed you guys this last week, I think. And you can press it, and it's 32 because this is stored as 32 in binary. So if keycode equals 32, then we're going to say player dot shoot. Okay, so now let's try this. Okay, that just broke a bunch of stuff. Okay, we can get rid of all this logging. Okay, that's just great. Console log this dot bullets. Boom. Alright, so we have one bullet in there, and our X is undefined and our Y is not a number. Wow. That's fun. Oh, okay. I forgot. Restoring location. And then our Y value is here. Try this again. Boom. Not sure why it shifts everything to the left, up and to the left though. Alright, we have 1,000,000 bullets. But we're not updating the bullets. So in our update sprites, we need to player.update bullets. Calling this function right here. Boom, pew 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 pew. So we can't hold it down, but we can let go and shoot. See how fast we can do it. Alright, so every time we update the bullet, so if you can see, we have 118 bullets, and that's not good for memory. So every time we update the bullets, we need to check if our bullets, which we're storing, so our X and Y values are the center. So it'll be fine. So if our bullet dot y is less than 0, then we're going to say else we're going to update. So we're actually going to change this so that we can get the index. We are going to let I equals 0. I is less than this dot bullets dot length. I increments by 1. Okay, so now we're going to change this to bullet I. Okay, bullet I. So now we're going to say, so if it's greater than 0, so we need to take an element. So I believe we use splice to remove an element from an array. So you can look at MDN docs here. So we are going to take our array. So we're going to say this dot bullets dot splice. We're going to set the index to be I. We're going to remove 1. So now, bullet is not defined. Player line 36. If bullet, whoops. Let me just do this real fast. Let bullet equal this dot bullets I. That'll fix that. Okay. So now, as you can see, after they go off the screen, they get deleted from the array. So now we don't have any more than we have on screen. Then we don't have to worry about any memory leaks. Yay! Also, why are they displaying on top of the player? I thought I definitely, because I definitely did not. So we need to display the bullets first so that they come from behind the player, just because I want it that way. Now they come from behind the player. There we go. Still haven't figured out that shifting thing. Okay. So now we need to be able to hurt players. So we need to be able to detect when one of these guys hits one of these. So this is kind of some hard computation. So we're going to need to check collisions. Actually, so I'm going to handle the bullet collisions inside update bullets. So we're going to pass in the enemy. Enemy location. So in our sketch, we update. Oh, well, actually, no, my bad. Enemy and enemies. So we're going to pass in the array. So after we update, actually, so before we, no, so after we move our player, okay, we are going to, so we're going to need to be able to remove enemies. Okay, so we're going to do this on upper level so we can access everything we need. So we're going to need to check collisions, because that's what we're doing. So we're going to look at each bullet, because we don't need to look at each enemy. Well, we do. So we're going to figure out, so we're going to say let B, just because we're looking at bullets, and B has to be less than player dot bullets dot length B plus plus. So now that we have each of the bullets, so for each of the bullets is going to check itself against all the enemies. This is not the most efficient way. Let me get that clear. It's not the most efficient way to do this. Well, actually, so we're going to swap this. So each of the enemies is going to check itself against the bullets. So let E equals 0, E is less than enemies dot length E plus plus. Okay, so for each of those enemies, it's going to check each of the bullets, because there's not as many bullets. It's going to do the same amount of computations. So for each of those bullets, it's going to say if, so we need to check if it's in our box. So how do we do that? We check our x and our y plus our width and our height. All right, goodbye, adios. So we're going to say if, actually, so we're going to let enemy equal enemies E. Okay, and then we're going to define each of our bullets. Bullet equal player dot, just so we don't have to type this each time. So if our bullet dot x is greater than, so remember we're drawing from the top left of our enemy. So our enemy, just bear with me, x and y, okay, is greater than our enemy dot x, and our bullet dot x then it has to be less than our enemy dot x plus our enemy dot size, or we can look at our just global enemy size. Okay, well, actually no, this is better. Enemy dot size. Okay, and our bullet dot y is greater than our enemy dot y. Thank you. And our bullet dot y is less than our enemy dot y plus our enemy dot size. So this should give us anything that's inside the box of our enemies. So if they're touching, then we're going to say enemies dot splice. We're going to splice it E for 1. And then we're also going to remove bullets dot splice at B. I'm going to remove 1. Okay. Actually, so then every time we update our sprites, we need to check our collisions as well. So here, play is not defined. Mine's 76. Oh, because I said play, not player. Okay. So it seems we broke it. Oh, well, I don't have the console open. So, players. Yep, player needs to be player. Okay, why is it not? Oh, there it goes. Here we go. Doesn't always work. Why is that? Let's lower our enemy count. Oh, I bet you it has something to do with that shifting. Oh, and I can go off the screen too. So everything shifts to the left and up, I believe. Yeah. So why is... Oh, okay. So what happens is we're changing our rectangle mode, but we're not changing it back. So in our sketch, when we draw everything, let's just set our rectangle mode here to be, what's the corner? Here we go. So this is the normal rectangle mode. Okay, not sure why it changes. Only while there's... Oh, because I forgot to save my player. Okay, now we can kill our enemies. Boom. So, we also need to slow down our enemies. They shouldn't be that fast. We're getting to be close to done. This is, how long has this stream been? We've been an hour and 10 minutes. We're almost done, actually. So now that we checked for all of our enemies, now that they check themselves against the bullets, now we can actually check ourselves against the player. So now we can kind of copy some of this. Okay, so we're going to need a function game over. So we're going to check if we hit one of those. So we're actually going to give ourselves 3 lives. Okay, and we're going to display those lives by going to, we're going to display some text, capitals, and it's going to be at 0. We're just going to move this out here real fast. Update, draw sprites. 0, height, minus 12. Oh, well, first we're going to give it the text, player.lives. Oh, so we need to fix this. So first, so we need to just check if player.x, but we actually call player.location. So we actually should probably set this dot y to equal this. Oh, I didn't realize you could access height and width inside. Okay, I'll fix all of that when we go and when I upload the final version to GitHub. Okay. So player.y, player.y. Okay, so this is going to check. So this is going to check if their top left corner is in there. But the issue we run into is, what if it just so happens to clip the top left corner, but the top left corner, the top right corner, but the top left corner of our player doesn't enter it? It won't know. So what we need to do is okay, so if our location is greater than or equal to and our location I got it. So if our location is greater than enemy x minus enemy dot size, so this is if our top right corner is barely touching them, and it's less than enemy x plus sizes, so our top left corner is touching their top right corner, okay? And then our y's are, and then if we're inside, that part doesn't matter. Then we're going to remove the enemy, and we're going to say player.lives minus equals 1. It's going to subtract 1, and then if player.lives is less than equal to 0, just as a precaution, then we're going to call game over. If we lose all our lives, game over, and we're just going to say console.log. We'll just put an error so it pops up and we can see it. Game over. Okay, so as you can see, we have our life counter here. We can pew our enemies, but if we get hit, oh no, we have 2 lives left. Oh, we have 0. Game over. Okay, so okay, so I just realized, so what happens is if you are here and you run into them right now, it will not work. So we need to do the same thing here we did. So we need to say minus enemy dot size here as well. Okay, and so we can have a global variable game over to which we'll set to true or false at first. Okay, so we'll stop, we'll only update them if the game is not over, and then if the game is over, is text size, is it? Let's check. Text size, we don't need 2 of these tabs open. Just make it like 20. Set our fill, autocomplete to be 255. And we're going to display the text game over for top of this from 0, 0 to width, height. We're also going to set our text online to be center. And yes, this needs an opening parenthesis. You know, 1 person still on YouTube. Wonder who that is. Hey, comment if you're watching on YouTube right now. Let me know. Let me know you're out there. Okay, game over has already been declared at 110. Oh, Just change this to be lowercase. This is not good to do, but I can't have a function the same name as a variable. Okay. Let's just shoot one of them just because I like them. I like shooting them. Oh no. Game over. And it freezes. Great. Perfect. Also, our bullets are coming out of our left. We need to fix that. So if our bullet, change this to be this dot y plus this dot size divided by 2. Okay. Now our bullet should come out of our center. There we go. Okay. So now we have a working Space Invaders game, pretty much. We probably should keep track of score. So let's just create a global score value. We're also probably going to need to implement levels so that if all the players or all the enemies are dead, then we need to spawn a bunch of enemies. So our score is going to be 0. When we draw our sprites, we're going to draw it. We're going to draw it in the top left. So 0, 0. Oh, well, 0, 12. Okay, so now we got our score. We're actually going to say score. In here, we're going to say lives. Sweet. We should probably make this a different color. Let's generate a new random color. Something that's not like turd colored and or vomit colored. Preferably. That's a nice contrasty color. 206, 84, and 95. All right. There we go. Now it's a nice contrasty color. Now you can see your lives. Oh no, game over. Not sure why it like blows up all of a sudden. Maybe because we're doing error here. But okay. Wow, we barely missed him there. So if we hit them, I'm not sure why that does like that, but so if we hit them, we need to have our score. We're just going to give you 100 points. No, 10 points for each player you kill, each enemy you kill. Sweet. Okay, so we got a score. We need to do levels, so level equal 1. And we're going to add, I don't know, 5 enemies each level. So, oh, we also need to make it so that if they get to the bottom, then you lose. We're not going to make the enemy shoot just because trying to make a game every week. So that's my goal. I know it's been 2 weeks of making this game. Just haven't had a lot of time lately, but hopefully I can make it to be a game a week. Okay, so our levels, so we're going to change this. Okay, so it'll be spawn enemies So we're going to create a new function all the way down here. And put this in here. Okay. So after we kill them all, we need to check if enemies.length does in fact equal 0. Then we're going to have to spawn our enemies, but first we're going to do, so we're going to do level plus equals 1. Then we're going to take our enemy count, set it to equal 10 plus, no, 5 plus our level. We'll just set it to level times 5. How about that? So we'll start out with 5 enemies. Total enemies across is not defined. Right, let's just make these global variables. Okay. Alright, so let's kill some enemies. One more left. Boom. Alright, now we got, oh, alright. I'm liking this, liking it. Oh, game over. So we also need to make it game over, which, to be honest, we don't really need this function of game over. We also need to make it so that if our enemy makes it to the ground, our game is over. We can't allow that. So after we check our bullets and our player, then we need to say if our enemy dot y plus enemy dot size is greater than height, and if it is, game over equals true. So now we need to slow down our enemies just because they can't be that fast. Our enemies are pretty fast right now, and Space Invaders, they're pretty slow. So as our let's actually do this. 0.01 times our level. So as we go up in level, it should be getting faster. It's a little too fast. Plus 0.01. Perfect time to test this. Wow, game over. Times our level. So we'll add 0.01 to it for every level we complete, and our max speed should probably be like 1. So in our enemy, remember our color, our max speed probably be 1. And we already started at 1, so we need to subtract 0.01 from them. Okay. All right. Okay, so there's one thing we need to do, and that is if you get a high score, you need to submit your high score, right? So I've already created an API that runs in the background. All we have to do is make a post request to it. See, these players are getting more and more orange because they're getting faster. And there's getting to be more of them. This is actually pretty difficult, or it'll get pretty difficult. So you can sacrifice yourself and get in the way of them. I'm just thinking, is 5 too many at once? I don't know. I guess we can leave it like this. So what's going to happen is there's going to be an API in the background that'll accept your high scores. I'm thinking our player moves a little too fast, but anyways. Also, we need to clear our bullets in between each round. Let me actually fix that. Player.bullets equals a blank array. So in between each round, if I have bullets in the air already, I don't want them to continue. That just gives an unfair advantage. See, there we go. Now I clear our bullets. Start fresh. All right. So we need to add the functionality to submit our high score. Whoops. So somehow we need to get access to make an AJAX call. So can we use jQuery in jQuery in p5.js? We can, then that'll make this really easy. For AJAX requests. Okay. Why are you still trying to define it here? Don't do that. Okay. So if our game is over, so we need to add in our jQuery. So let's just look up the jQuery CDN. So CDN is a content delivery network. It just keeps an online version. We just want the minified version, because I believe the slim version does not include AJAX. If you're unfamiliar with this, I would definitely recommend just finding some tutorials online. It's a really good library, especially for beginners. So, if our game is over, we're going to make an AJAX request. Okay, so let me actually define this in here. we're going to get high scores. So this is going to be, it's going to be an Ajax request. And so this is going to be the let's open up the what is it, jQuery core. Where's the docs? Where's the docs? API.jQuery.com. Gotcha. All right, so we're going to pass in some settings. Okay, does it take a URL setting? It does. So our URL is going to be localhost, and our API runs on port 3000. And we're going to call high scores, because I believe that's how I set it up. So let me check real fast. Nope, so we just call slash, okay. So if we just call that, and it does run on, port 3000. So we're going to get that. And then on success, we are going to success, and then it's the data. So we are going to call got high scores, pass in the data. Error is going to be function JQXHR. We're going to get a text status. We're going to get an error thrown. We're going to just console.log JQXHR. We're just going to copy these guys into here, just because we want to see all the output when it errors. So let me get this running. So we're going to cd into our backend folder, and then we're going to call yarn dev. Okay, so this is going to start up our backend. Okay, so our backend should be running. We're just going to define a function real fast. Got high scores. It's going to accept data. We're just going to console.log that data. So if it game over, we call get high scores. All right, so now we wait for these guys to kill us. I think it would be faster for me to just kill them and get some faster people. Alright, sorry for the keyboard noise if you're hearing this. Oh, wow. Come on. Go faster. Go faster. Go faster. How did I miss that guy on both sides? Alright. They're almost here. They're almost here. They're almost here to kill me. I feel like we move a little too fast. Alright. Lives 1, 0. Okay. From origin, null has been blocked by cores. Oh, right. HTTP, data chrome. Okay, I dealt with this in my high store GUI. 1 second. Check the logs. I dealt with this before. How do I set the origin? Cross domain true. We can try it. At least it's running. That's a good sign. Let's just run get high scores. Origin null. Ah. Alright, so we need to not host this. We need to do, alright. I remember doing this. Okay. So we need to host this on a local server because it will not allow us while we're accessing it. I thought I had set this up before the stream, but I guess I forgot. So now we need to get access to all these files. So it thinks that we're trying to access a local folder here. No, just for the sake of it. Just for the sake of it. I know this won't help with sizes, but just for the sake of simplicity and of this video. Localhost has been blocked by cores. It is HTTP. All right, let's fix our back end. All right, simple enough. I already have this in there. Doesn't make sense. Okay. Nope. Sorry for the headphone noise. Just gonna take my headphones off for a second. Sorry for that. So I allowed this. And the thing is, okay, did that restart it? Okay, restarted. Still blocked. All right, let's do this. Let's add cores. Since it wants cores, yarn add cores. Let's try using this. This needs to be resolved. All right, see if this works. Nothing. Let's try and just restart all of this. restart the HTTP server 2. And we still get nothing. This is working when I so I made this high score GUI thing so that I could see all this, and it's working, but I don't know why. Oh, I am not specifying URL. Maybe that's specifying, and I'm saying, let me copy this exact. Oh, I'm saying HTTP. Maybe that's it. All right. Server stop. Space Invaders. Just sweet. So the AJAX request returned. Reference error got high scores. Is not defined. Didn't I define that? I swore I defined that. Oh, got high scores. All right. So that returns. Okay, all of our high scores. So now we're going to keep a blank list of high scores. Okay. Actually, we're going to document.ready. Okay, so it's going to get the high scores when it loads. Close that out. Then we're going to say high scores equals data dot filter. So okay, so array filter data dot filter. Then we pass in the score, and it has to score dot game ID equals 1 because 1 is Space Invaders. So we set all of our high scores, and then we can display them. High score display that'll equal create p. Okay, so I'm going to do that. It's not going to have any text. It's going to say high scores. Make sure that works. Okay, so high scores are here. So then So splice gets rid of them. So high score display dot. So we need to go to our P5 DOM library. DOM. So now we need to say element dot so we can say high scores dot slice 0 to show the top 5 dot map. So we're going to take score and we're going to return score dot return a string that's so it's their name. So here score dot name dash score dot score. Okay. The new line off the end. We're going to append this true. Refresh. Got high scores is not defined. We have .html. Here we go. So our new line isn't working. Okay, we have a list of high scores. Oh, we've been streaming for 2 hours. Probably have to finish up soon. I'm going to change this to say top 5. So then if at the end we need to say, whoa, why is it getting, why when the game is over, it calls get high scores? So we need to create a div. So high score div. Then we need high score input, high score submit. Okay. So, well, let's say high score label. So our high score div, create a div. Okay. It's gonna have nothing in it. Just gonna be a div. Okay. Then we're going to, there's a way we can, so we can child the element. And say high score label equals create a P, enter your name. You got a high score. Okay, cool. Also gonna need high score input equals create input. Default value.
I'm gonna be leaving to go out to eat for dinner at 7:30. Are you gonna be ready?
7:30? Yeah, I can finish up right now. Alright, so I have to go soon, but what I don't finish on stream, I will finish, and I should use OpenGL. I'm not sure if P5 uses OpenGL in the backend. bless you, excuse me. So our high score submit. Create a button. Submit. So we got the high score label. Actually, we're gonna do high score display dot child the label. We're gonna child the input. Then we're gonna child the submit. Okay, and then we're going to hide this all. So the div dot hide. Okay, so here, boom, reload, it's not there. So at the end, we need to get high scores. Oh, no, we don't have to. So, we can change this just to say, enter your name, submit your score. Because then we have to, if they got a high score, just if they submitted their score. So, high score, div.show. So show the, show this. Just need to do it here. Um, okay, so submit score. Um, okay, this dot value. Ah, okay, so submit score. We need to say here our button high score submit dot mouse press. Okay, we're gonna say submit score. Can I just do it like that? I think button. Yep. Here we're gonna duplicate this. Okay. Okay, so then we're gonna make the method be post. Okay, so we're gonna post a score. Okay, data. So I can't remember when we handle a post request. Yep, the request body. So our data is going to be in the format of game ID, score, and name. So our game ID will be 1 because this is Space Invaders. Our name will be high score name, and our score will be score. And this ID must be true. Then what happens when we finish? Else it will return a 201 status. So yeah. Okay. So let's run this. And this should work. Let's get up our score here. Make these enemies go faster. Oh, hey, what's up, Austin? Got our coming. I don't know if you're coming in late or not, but we got our basically finished Space Invaders game here. I can't get these two guys. There we go. Yeah, just for testing purposes, just because I don't want to sit here. Let's change this to. Let's turn this up. All right, let's die. There we go, and nothing happens. Just like shoot it. Yeah. I wish. Hide. show. So there's nothing inside of it for some reason. It is there. There's nothing inside of it. Maybe I'm childing wrong. Parent. Attaches the element to the parent specified. Ah, there we go. Except for the fact that the label isn't displaying. Alright. So what we're going to do. Copy this, delete, paste, save, copy, paste, copy, paste, copy, paste. Lots of copy and pasting. Alright. Boom. Alright. Bradley. Submit. Yeah, console error. High score name is not defined. Sick. High score input dot value is what I need. Loading. Yeah. Alright. I'm gonna have to look into this because I have to go. But yeah, so we got our working Space Invaders game. I'll fix the speed and stuff. But there you go. There we are. It's Space Invaders. Hope you all have enjoyed the stream.